Hey everyone, welcome to today's video where we're diving in the most important part of your AWS Certified Cloud Practitioner exam preparation, mastering how to answer questions quickly and correctly. You've got less than 2 minutes to tackle each question. That's not a lot of time, right? But don't worry, by learning how to break down questions efficiently, spot key phrases and eliminate distractors, you'll improve both speed and accuracy. In this video, I'll guide you through 10 typical exam questions for the CLF-C02 exam. We'll focus on how to break each one down, identify the critical keywords, examine and understand the scenario that the question poses, and then eliminate any wrong answer options to get to our correct answer. Together, we'll work through each question step by step, showing you how to spot what the exam is really asking and how to avoid common traps that slow you down. So grab your notebook and get ready to learn some techniques, and let's jump on to our first question. And question number 1 is, you must ensure that all IAM users have a complex password configuration with a minimum of 12 characters consisting of capital letters, lowercase letters, numbers, and at least one symbol. Passwords must expire every 42 days. Which IAM feature should you configure to meet these requirements? Now, if we take a look at the key phrases here, the first key phrase that I want to point your attention to is complex password configuration. So we know we're dealing with passwords and we want to make them as complex as possible. What's more, these passwords are for our IAM users. The next keyword is IAM feature, which basically tells us that this is a feature of the IAM service that allows you to create complex passwords. And obviously it gives you a little bit of a background around, what that complexity needs to look like, the 12 characters, the lowercase letters, the symbol, etc. From the answer options then, you've got password policy, service control policy, IAM policy, and password complexity tool. The answer, and I'm pretty sure you guessed it already, is going to be password policy. Password policy is a feature within the IAM dashboard that allows you to configure complex password configuration. It's not service control policy because service control policies are similar to IAM policies that enable you to define guardrails for what services and actions can be performed in an individual AWS account. So it is a policy applied at the account level. For instance, you may have a dev account where you just want to enable Amazon RDS, S3, and DynamoDB perhaps, and you don't want to enable all of the other services. Service control policy can help you limit that by applying those guardrails. IAM policy is yet another policy that you apply to IAM identities and principal and define the level of authorization that they have in your AWS account, what it is they can or cannot do. So those identities and principals, can they launch EC2 instances or can they terminate an EC2 instance? Can they create an S3 bucket or deploy a DynamoDB table? Those permissions are defined in an IAM policy and have got nothing to do with passwords. So answer C is incorrect as well. And then finally, password complexity tool. Now, if you've done your studying, then you will know that there is actually no such tool. This is just a distractor, just to try and confuse you. There is no such thing as the password complexity tool. The answer is password policy, and I'll show you a quick screenshot of where that is. So within the IAM console, you'll go into account settings, and that's where you can configure your password policy. You can define a password policy with the minimum number of characters, whether you want to use uppercase, lowercase, letters, numbers, non-alphanumeric characters, so those are the symbols, whether or not you want to set an expiry date for them. So here we can set the 42 days of expiry date, and you can also define whether or not you can use previous passwords and how many previous passwords are you not allowed to use. So hopefully you were able to get this answer correct. Right, let's move on to question 2. So question 2. Which AWS service can help you monitor performance metrics for your EC2 instances, such as CPU utilization, and then configure alarms to send out notifications if thresholds are breached? Let's take a look at the key phrases here. So we want to monitor performance metrics. And if this is a little bit confusing what we mean, well, we've got an example. CPU utilization. So CPU utilization is a specific performance metric relevant to your EC2 instances and in fact other compute services on the AWS platform. Okay, you get to see how much CPU utilization you're consuming of that particular resource, such as EC2 instances. The service also allows you to configure alarms, and then you can send out notifications if you cross specific thresholds that you've specified in the alarm. Hopefully, you've done your studying and you know what the answer is. It's going to be Amazon CloudWatch. So Amazon CloudWatch is a service that allows you to monitor metric information of all of your different resources that you deploy on the AWS platform. CPU utilization, network bytes in and out, disk read-write ops, etc. CloudWatch is a very versatile service, and it integrates with pretty much all the other services on the AWS platform, allowing you to perform monitoring of those resources. And you can configure alarms that can be triggered when specific thresholds that you have defined are breached. You can use those alarms to send out notifications, launch a new instance, replace an existing instance, and do a lot of other similar automated actions. Now, answer B is AWS config, and AWS config is incorrect because AWS config does not let you monitor metrics of your resources. Instead, what it does is it allows you to define configuration settings and rules for any resources you wish to create in your AWS account. So what you do with config is you basically set rules as to how a particular resource needs to be configured and deployed. And then you can use those rules to define compliant and non-compliant resources against those rules. Answer option C is AWS CloudTrail. Now, AWS CloudTrail is a service that allows you to audit the actions that you take in your AWS account. Every API call you make, every request you make in your AWS account to launch an EC2 instance or simply to log into the AWS account is logged in CloudTrail. Answer option D is AWS Lambda. AWS Lambda is incorrect. It is not a service that will monitor metrics of your EC2 instances. In fact, it is another type of compute service, or more precisely, a serverless compute service that allows you to trigger compute function, i.e. run code, in response to events or at scheduled intervals. With AWS Lambda, you don't have to manage or host EC2 instances to run your compute processing. Instead, you simply trigger code in response to an event or at a particular schedule. Here's a quick screenshot of CPU utilization. In fact, this is actually an EC2 dashboard screenshot, but it's showing you the CPU utilization metric that's ultimately being recorded in CloudWatch. Okay, let's move on to question number 3. Which AWS service highlights potential security issues and offers recommendations in your AWS account, such as the root user not configured with MFA settings? Now, you know what MFA is. That's multi-factor authentication. It's highly recommended that you always have at least a minimum of 2 forms of authentication in order for a system to verify your identity. So you got your username and password, and then perhaps you have a one-time password PIN that gets generated every time you try to log in. Okay, so let's take a look at the key phrases here. So we've got highlights potential security issues. So there's a service that provides that kind of information, and it offers recommendations on how to obviously mitigate those potential security issues. So which AWS service actually does that? So you've got AWS Trusted Advisor, Amazon Macie, the Service Health Dashboard, and Guard Duty. Now, the correct answer to this one is obviously Trusted Advisor. The service provides recommendations across 6 different categories: cost optimization, performance, security, fault tolerance, service limits, and operational excellence. Now, service limits is basically where it tells you whether you're approaching a specific limit or a quota within your AWS account. This particular area where it's telling you that you haven't configured the root user for MFA settings, that's going to fall under the security category. Okay, so going through all of these different 6 categories, you're able to identify any issues, any problems, and recommendations for improving your performance or operational excellence within your AWS account. Obviously, the answer is not Amazon Macie. Amazon Macie is a data security service that uses machine learning and pattern matching to discover and help protect against sensitive data. Think personally identifiable information, PII type data, in Amazon S3 buckets. It's not the Service Health Dashboard. That's simply a dashboard that tells you all of the different AWS services and if there are any outages. And then it's definitely not Amazon Guard Duty, because Amazon Guard Duty is a threat detection service that continuously monitors your AWS account and workloads for malicious activity and delivers detailed security findings and visibility and remediation. So it's not a potential security issue, and here are the recommendations to fix it. That's what Trusted Advisor is. GuardDuty actually is a service that will monitor for malicious activity as well. Okay, so it does something slightly different than what Trusted Advisor does. Right, let's move on to the next question. Okay, so question number 4. Your front-end developers are building an application that requires sending push-based notifications of new video uploads to an S3 bucket across multiple SQS queues. Which AWS service offers the parallel publishing of such notifications on AWS? Right, a little bit more complex of a question, a bit more scenario-based that you're likely to start encountering in the exam for the CLF-C02 exam. Now, here are some keywords here. So we want to send push-based notifications of new video uploads to the S3 bucket. Essentially, every time someone uploads a video to an S3 bucket, a notification needs to be sent out. So S3 needs to trigger a service that sends out such notifications. And with S3, we have something called event notification that can trigger something to send out the necessary messages or notifications here. The next key phrase is multiple SQS queues. So multiple SQS queues. So the SQS queues, simple queue service, queues, are the subscribers of those notification messages. Okay, so we're sending push-based notifications to who? We're sending it to the SQS queues. Which AWS service offers the parallel publishing of such notifications on AWS? So there is a service that will allow you to send out these push-based notifications to multiple SQS queues parallelly. Okay, so obviously, if we are sending it to SQS queues, and it's a push-based notification, it's not going to be Amazon SQS, because Amazon SQS is a pull-based messaging service. It's a queuing service that allows you to decouple your application stack. Instead, it's actually going to be the Amazon SNS service, because the Amazon SNS service is a push-based messaging solution that allows you to send out messages whenever it's triggered, okay? And in this case, it would be triggered by whenever someone uploads a new video to an Amazon S3 bucket. And if we take a look at the parallel publishing requirement, well, let's take a look at a diagram. So we've got a publisher that essentially triggers the SNS service, a push-based notification. And SNS has the capability to send out multiple notifications parallelly across different subscribers. In this case, we've got multiple SQS queues. And what are these SQS queues doing? Well, they're basically holding the message in a queue for your application service to retrieve the message, what video has been uploaded, and then to go out and get that video, and in this case, perform 3 different actions: convert to MP4, convert to .mov, and convert to AVI. So different video formats is what this application is doing. So you've got the publisher, in this case an S3 bucket. It triggers an event notification whenever someone uploads a video. That gets the SNS service to send out a push-based notification to these multiple queues. The app service will then retrieve those messages from the queue and process the video so that this particular application server converts it to MP4, this one to MOV, and this one to AVI. That's the architecture. It's definitely not Amazon Kinesis data streams, because Amazon Kinesis data streams is a streaming service that makes it easy to capture, process, and store streaming data in real time. Okay, so we're not streaming data here. We're basically just triggering a notification whenever someone uploads a video to an Amazon S3 bucket. And it's definitely not Amazon QuickSight, because that's a business intelligence tool that builds visualizations, performance, and ad hoc analysis, and quickly gets business insights from your data. Totally different piece of service altogether. Right, let's move on to question 5. Okay, so here's the next question. Which AWS service offers a visual console to help you coordinate the components and steps of your application's various functions and represent its logical workflow? So you've got step functions, SNS, EventBridge, and CloudWatch. Key phrases here are you're trying to coordinate the steps of your application's functions and represent that in its logical workflow. So there's a service that will help you architect the workflow of your application from start to finish. Its different components, its different activities, decisions as part of that workflow, and you need to be able to identify what that service is. And the answer obviously is AWS Step Functions. So AWS Step Functions is a really amazing tool. You can basically build your entire application workflow using this service with its visual representation, and it's integrated to trigger all of the different services and infrastructure technologies that you use as part of your application design architecture. It allows you to visually design your workflow using state machines, which define the sequence of tasks, decisions, and error handling steps. You can easily break down complex processes into smaller, manageable steps, ensuring reliability and enabling the integration with services like Lambda, ECS, S3, without having to manage the underlying infrastructure. It simplifies the creation of scalable, fault-tolerant systems. So in this design architecture, this is a sentiment application. So we detect the sentiment, we generate a customer order number, we record the transaction. If that is good or bad, we then make a decision, and this is where we make a decision step. So if it's good, then we just end. If it's bad, we send out a notification to an administrator with the fact that we've had a bad experience. This is just one small component of perhaps a much larger application, but hopefully you're beginning to see how step functions can help you build end-to-end solutions far more quickly and easily. Okay, so let's take a look at the incorrect answers. Here we have Amazon SNS, which is a simple notification service. We looked at that in the previous question. That's definitely not what this is. Then you've got EventBridge, which is an event triggering service, which basically uses event buses to help you build event-driven applications. So when something happens, you could trigger a Lambda function, or you could send a message to an SQS queue, or trigger an SNS notification. That is what EventBridge is used for. And then obviously CloudWatch, which we had a look at earlier, is basically a monitoring service, monitors performance metrics across your different resources on the AWS platform. Right, let's move on to question 6. Okay, so this is the next question. Which AWS service enables you to trace and analyze application behavior, making it easy to identify performance bottlenecks? So the question refers to identifying performance bottlenecks, performance issues with your application. You've got AWS WAF, Amazon X-Ray, Amazon Detective, and Amazon Macie. Right off the bat, hopefully you're going to take Amazon Macie and throw it out of the window, right? Because that is definitely not the correct answer. What's AWS WAF? Well, that stands for Web Application Firewall. So it's a firewall service, not a performance bottleneck service. What about Amazon Detective? Well, Amazon Detective is a security service that helps organizations investigate, analyze security issues of suspicious activities in your AWS resources. So it doesn't actually do any kind of performance bottlenecks. And in fact, I actually missed this part, right? We need to look at those key phrases. So we are tracing and analyzing application behavior, and we're trying to identify performance bottlenecks. Naturally, you're going to select Amazon X-Ray. Of course you are, because Amazon X-Ray is the service that will help analyze the way how traffic flows through your application and identify specific metrics on how that application performs. Okay, so if we take a look at an example of a application here, you can see that the application comprises of different components, different technologies. In this case, we're just looking at a snippet of that segment's timeline. We're looking at the DynamoDB element of it. And on the right-hand side here, you can see what's actually happening. We're getting some items. So something called a score keep game, a score keep state, etc. And the segment status tell us whether it was successful, that particular operation within the application, the response code being 200, which means yes, it was successful, and the duration. The duration tells us how long it took us to actually get that particular item, for instance. Okay, so we're running a post request against a particular URL endpoint there, and those are the different transactions. So X-Ray drills down to the minute detail of your application performance, its different components, and its interactions overall from start to finish. Amazon X-Ray allows you to trace and analyze application behavior and identify any performance bottlenecks. Let's move on to question 7. Okay, so the next question is, which AWS service can be used to obtain information about how an EC2 instance in the US East 1 region was terminated? Okay, so now we want to do some auditing here. We want to analyze how a particular EC2 instance was actually terminated. So you've got AWS config, okay, which is basically configuration rules that you can apply to how your resources are configured. It's definitely not that. We've got CloudTrail. In fact, that is the right answer. AWS CloudTrail is an auditing service that will record all of your API actions in your AWS account. So if you hit an EC2 instance with a termination request, that's going to get recorded. CloudWatch, well, that doesn't actually record how things happen. It mainly records performance metrics. And then Trusted Advisor, we've discussed this already, is a service that will look at how your various resources have been configured and then provide some recommendations on best practices. If we actually take a look at a screenshot of a CloudTrail event history, you can see here how that information is presented. So in CloudTrail, we're able to see the instance that was terminated, okay, when it got terminated, which user initiated the termination request, the source IP of that termination request, and so on and so forth. Okay, so you've got all that information for auditing purposes available to you in CloudTrail. Right, let's move on to question 8. Okay, so here's question number 8. So which of the following are features of network access control lists and ACLs? You've got to select 2 answers. So this is a multi-select question format. You've got 5 options and you've got to select 2 of them. So the key phrase there is obviously we're looking at the features of network access control lists. And so you must know the differences between network access control lists and security groups when you're building your VPCs. Answer option A, they are stateless. Absolutely. Network access control lists are in fact stateless. What that basically means is that you have to create both your inbound rules and their corresponding outbound rules as well. So if I allow inbound traffic from a particular source on port 80, I need to ensure that the outbound traffic is allowed on port 80 to that destination. Okay. Unlike security groups, which are stateful, you don't need to do that. Once you create an inbound rule with security groups, the corresponding outbound response is automatically permitted. So security groups are stateful, network access control lists are stateless. Also, network access control lists support both allow and deny rules. So you can create an allow and a deny rule in network access control lists, and I'm going to come on to that in a second, but you can't do that with security groups. Security groups only let you create allow rules. Everything is denied by default, and then you define what you're allowing, okay? What you're going to allow to hit your EC2 instances or your RDS instances as part of that security group. Answer option D, they restrict access to S3 buckets. No, they don't, okay? NACLs work within a VPC, and you do not place S3 buckets in a VPC. They enable establishing VPN connection. Well, they do insofar as they allow the rules or the traffic to flow, but actually enabling VPN connections, that's a different service, okay? That's the VPN service itself with the virtual private gateway and your customer gateway that you need to configure. Okay, so when it comes to features of network access control lists, they're stateless and they support both allow and deny rules. And if we take a look at an example of a network access control list, so the way how it works is the rules are written out as a rule number. Okay, so you've got rule number 50, 60, 70, 100, etc. Or you can start at rule number 10, 20, 30, and so on. And what you want to do is you want to define any kind of deny rules to have a higher priority before you have more broader allow rules. So let me give you an example. In this example, we've got rule number 100 that says I'm allowing port 80 from anywhere on the planet, and that's an allow rule. So anybody on the internet can access my resource on port 80, which is the HTTP port. Then I'm denying anyone from this IP range to be able to access my service on port 80. Okay, so rule number 50, which obviously in terms of a number hierarchical structure comes before rule number 100, is being applied first before rule number 100, which is the more broader allow rule. Okay, if you reverse this, if you actually change this rule number to 10, for example, so this comes before 50, what's actually going to happen is this rule where we're trying to block any access from 192.168.10.0/24 is just going to be bypassed, okay? Because the more broader allow rule comes first, because I put it on rule number 10. So the rule numbering is really important. The lower the number of your rule number, the higher its priority, the higher its precedence. So you need to be careful about how you define your allow and deny rules when you come to set up network access control lists. Okay, hopefully that makes a lot of sense. Let's move on to question number 9. Okay, so question number 9 is a developer needs to dynamically retrieve database credential information stored in Amazon Secrets Manager for an application running on an EC2 instance. Which service is required by the EC2 instance to retrieve the credential data successfully. So you've got access keys, Amazon S3, IAM role, or environmental variables. Okay, so here the key phrase is we want to retrieve database credential information stored in Amazon Secrets Manager for an application running on an EC2 instance. So the EC2 instance needs to be permitted to talk to Secrets Manager. That's really what we are saying here. So how do we do that? Well, you could configure some environmental variables in your application to retrieve that data from Secrets Manager. Okay, so you could do that. So the application could be configured with some environmental variables that says, here's Secrets Manager, this is a secret, go and retrieve it. But you really need to look at what the question is trying to get you to do, which is to look at permissions. How do you give the EC2 instance the ability to retrieve that information? And so the answer actually is going to be an IAM role. Okay, so the EC2 instance needs an IAM role where the EC2 instance is trusted and it's got permission to go and talk to Secrets Manager to retrieve that database credential. You can't use Amazon S3 for it, okay, because that's not going to give it the permissions. And access keys, well, the access keys are where you define long-term credentials for an application to go and talk to a particular service, like, say, for instance, Amazon RDS or Amazon DynamoDB. Okay, but instead of using access keys, which is considered bad practice, you want to be using an IAM role instead. Okay, because an IAM role gives you temporary credentials and it's a lot more secure, rather than access keys, which are embedded in the application code, which could also be in plain text, which is a big security risk. Great, IAM role is the answer. Let's move on to question number 10. Okay, question number 10, which AWS savings plans provides the maximum flexibility by applying discount pricing against EC2 instances, Lambda, and Fargate compute services? So AWS savings plans allow you to basically commit to a specific dollar amount per month for a 1 or 3 year period of time. And if you commit to that dollar amount spent per month, the resources that you spend it on are discounted. Okay, so the hourly charge on that particular resource is discounted. So if you commit to say $100 a month, instead of paying the on-demand rate, you'll actually pay a discounted rate against that resource. And so your key phrase over here, obviously, is the fact that you want to apply the discount against EC2 instances, Lambda, and Fargate. And so what you need to remember is that actually AWS comes with 3 different savings plans. There's the compute savings plans, the EC2 savings plans, and the SageMaker savings plans. The correct answer here obviously is the compute savings plans, because what it does is it allows you to apply that discount against multiple different types of compute services, specifically EC2 instances, Lambda, and Fargate. The EC2 instance savings plans gives you a bigger discount, but it's only applicable to EC2 instances, hence the name EC2 instance savings plan. And then there's a third one, the SageMaker savings plan. Well, that just applies to SageMaker itself. Okay, so the answer to this question is compute savings plans if you want to apply discount against multiple compute services like EC2, Lambda, and Fargate. Now I've got something else for you. If you're very keen on actually getting access to a lot more practice exam questions to help you prepare for the exam, then you're welcome to check out my AWS Certified Cloud Practitioner CLF-C02 practice test course. This gives you 390 practice exam questions spread across 6 separate exams. And for each practice exam, there's 65 questions per exam. And what you do is you go through these practice exams, and that will help you prepare for the actual exam as well. For each set, you've got a revision mode. So once you've completed the exam, you can actually take a look at the revision mode, which actually walks you through all of the questions, the correct answers for those questions, an in-depth explanation as to why the correct answer is the correct answer and why the other answers are incorrect, and so on. And that will help you prepare for the official exams quicker, faster, enabling you to pass in the first attempt. Okay, so the link of this practice exam simulator is there in the description box below. Feel free to enroll into that to help you prepare for the CLF-C02 exam. Thank you.